In 2019, Dubai announced a new mega construction project called Skyrise Eco Tower. The goal was to build one of the most environmentally efficient commercial towers in the Middle East. The building would be over 40 floors and required advanced structural engineering with strong sustainability performance. The project attracted engineering proposals from Europe, Asia, and North America. The final decision authority was given to Hassan Al-Kotri, Senior Structural Director at Desert Core Construction Group. Hassan had worked in high-rise construction for nearly 30 years. He was involved in multiple landmark towers across Dubai and Abu Dhabi. None of his projects had major structural problems. Because of that, developers trusted his judgment without questioning it. His office was located on the top floor of Desert Core headquarters. The walls displayed photos of completed skyscrapers and several international engineering awards. One afternoon, his assistant placed a new proposal file on his desk. This arrived from the Philippines, she said. Hassan looked at the label. Company Novabuild Structural Systems, lead engineer Luis Mendoza. Hassan opened the file expecting a standard steel, concrete hybrid proposal. Instead, within the first few pages, he noticed something unusual. The design suggested using engineered bamboo composite lattice reinforcement combined with steel framing. He flipped more pages. Material testing results, flexibility stress data, wind vibration resistance modeling, carbon footprint reduction analysis. He stopped reading after about 20 pages. Then he laughed, not loudly but clearly dismissive. He pointed at one of the diagrams. They want to use bamboo reinforcement inside a skyscraper frame, he said. His assistant stayed quiet. Hassan shook his head. This is Dubai, not a tropical resort construction site. He closed the file. Mark this as rejected, not suitable for primary structure review. His assistant tried once. Sir, their testing data looks very detailed. Hassan replied immediately. I've built towers in this region for decades. I know what materials survive this climate. The proposal was removed from the active shortlist. Selection committee meeting. The next day, the project selection committee met. Attendees included project investors, government infrastructure representatives, sustainability certification officials, financial risk advisors. Hassan presented his recommendation. Iron Shield Engineering, Germany. Their design used advanced reinforced steel frame systems with deep concrete core support. Reliable, proven, but expensive. One committee member asked, what about the Philippines submission? It scored highest in environmental performance. Hassan responded directly. Environmental rating is secondary if structural certainty is not proven at this scale. Another member added, they projected 25 to 30% cost savings. Hassan leaned forward. Cost savings are meaningless if structural risk increases. No one argued further. The vote was completed. German firm selected. Philippines proposal rejected. 3 weeks later, the email. Hassan received an email from Luis Mendoza. The email was professional and respectful. Luis said he understood the concerns about bamboo integration. He wrote that he believed parts of the structural testing data may not have been fully reviewed. He mentioned he was attending an engineering conference in Dubai and asked for 30 minutes to demonstrate material behavior using physical testing. No request to reopen the bid. No complaints, just demonstration. Hassan almost ignored it, but he accepted the meeting request. The meeting. Luis arrived exactly on time, early 30s, simple business suit, carried a reinforced equipment case instead of a laptop bag. Hassan gave him 30 minutes. Luis opened the case and removed a treated bamboo composite cylinder about the size of a small pipe. He attached it to a clamp system on the desk and added weight gradually. 5 kilograms, no bending 8 kilograms, minimal flex 10 kilograms, still stable. Then he tested a steel tube with the same weight and size. At around 8 kilograms, the steel showed more bending than the bamboo composite. Hassan leaned closer. That result was unexpected, Luis explained simply. Engineered bamboo fibers distribute tensile stress differently than uniform metal tubes. When combined with steel frames, it reduces stress concentration at joints. Then Luis showed simulation videos on a tablet. Wind load modeling, earthquake movement simulations, long-term vibration fatigue comparisons. The hybrid bamboo steel system showed lower joint failure probability under extreme movement. Hassan did not interrupt. He realized something uncomfortable. He had never read the full original proposal. The important moment. Lewis said one direct statement. "I am not trying to replace steel. I am trying to reduce structural stress on steel." That stayed in Hassan's mind. After the meeting, he did not change any decision. But he did something new. He called his simulation department, run full wind load analysis on the German design again. Use updated storm data from last year. Run worst-case scenario models. That evening, Hassan sat in his office looking at the bamboo composite sample still sitting on his desk. It had not cracked, not bent permanently, not failed. And for the first time in years, Hassan asked himself one question. What if I rejected something without checking everything? 2 days after meeting Luis Mendoza, Hassan Al-Qatri received the updated simulation report for the German design. The results were not good. The structure passed normal wind load requirements, but under extreme storm simulation, based on updated regional weather data, the building failed safety margins by around 7 to 9%. That did not mean the building would collapse, but it meant reinforcement would be required. And reinforcement meant higher cost, longer construction time, possible project delay, investor pressure. Hassan requested a second independent simulation review. The results came back almost identical. Now it was a real problem. Internal engineering meeting. Hassan called his senior engineering team. They reviewed 3 options. Option 1, add steel reinforcement, result cost increase nearly 18%. Option 2, redesign core frame structure, result 6-8-month delay. Option 3, look for alternative stress distribution solutions, result unknown risk. That third option stayed in Hassan's mind because now he remembered the bamboo composite demonstration. The decision pressure. The project investors requested an emergency update meeting. The main concern was budget stability and timeline protection. The German firm was confident they could fix the issue, but their solution involved major structural reinforcement. The project risk department warned that further design changes could trigger contract penalty clauses. Hassan understood something clearly. If the project went over budget, his reputation would take damage. If the building failed safety margins, his reputation would be destroyed. Hassan reviews the Philippines proposal again. For the first time, Hassan opened the full original Novabuild proposal. He did not stop at page 20. He read everything, including the appendix sections. Inside were large-scale typhoon resistance case study, the 12-story hybrid structure performance data, the wind load distribution graphs, the joint stress reduction modeling, carbon life cycle analysis, the material aging durability projections. One case study showed a hybrid structure in Southeast Asia that survived a Category 5 storm without structural damage. The steel, only building next to it, required major repair. Hassan felt uncomfortable, not because the data was wrong, because he had ignored it. The second meeting with Luis. Hassan contacted Luis again. This time, not for demonstration, for technical discussion. They talked for almost 2 hours. Luis explained that bamboo composite lattice does not carry primary vertical load. Instead, it redistributes lateral stress energy and reduces fatigue load on steel joints. In simple terms, steel stays strong longer when stress is shared. Hassan makes a risk decision. Hassan requested one confidential simulation, not official, not shared with the committee yet. His simulation team modeled a hybrid structure based on Novabuild's concept, but applied to the German tower layout. Results showed a wind load stress reduced by nearly 15%, said joint fatigue life increased, a material weight reduced, or foundation depth requirement slightly reduced. Now Hassan had a serious decision. If he ignored this, the project would continue but with higher cost and weaker long-term performance. If he pushed for review reopening, he risked political and corporate backlash. The turning point meeting. The project committee met again. They were already frustrated because reinforcement costs were being discussed. Hassan spoke directly. The current design will require major reinforcement to meet new wind safety margins. The investors were not happy. Then Hassan continued, "There is an alternative hybrid structural method that may solve this." The room became quiet. One developer asked, "You mean redesigning again?" Hassan answered carefully, "I mean reviewing an existing rejected proposal." Some committee members immediately resisted. One official said, "We already selected the German firm." Hassan replied, "I recommended them. I also take responsibility if a better solution exists." That statement changed the tone of the room. The technical presentation. Hassan presented hybrid bamboo composite lattice integration concept, simulation comparison data, real-world case studies, material stress performance results. At first, the room was skeptical. Then they started asking technical questions, not dismissing anymore, evaluating. Finally, one investor asked the most important question: "Is this safer than reinforcing the current design?" Hassan answered honestly, "Yes, based on current data it is." The vote reopened. The committee agreed to allow a secondary technical review. Not a full project reset yet, but enough to bring NovaBuild back into consideration. Hassan contacted Luis. For the first time, the conversation was not between a rejected engineer and a decision maker. It was between two professionals solving the same problem. After the secondary review process officially started, NovaBuild Structural Systems was asked to submit a full structural integration plan for the tower. This did not cancel the German contract immediately, but it meant the project direction was no longer locked. For the next 2 weeks, both engineering approaches were tested using identical simulation environments. The German reinforced steel design required major additional reinforcement to meet updated extreme wind safety margins. The reinforcement plan increased total structural weight and pushed cost projections significantly higher than the original budget. The NovaBuild hybrid reinforcement model was tested using the same tower geometry. The bamboo composite lattice was integrated only as a stress distribution system, not as a primary load-bearing core structure. Simulation results showed reduced lateral stress concentration across key joints. Long-term fatigue simulations predicted longer structural lifespan under repeated high-wind stress cycles. Total structural weight was also lower compared to the reinforced steel-only upgrade. The committee reviewed both reports carefully. This time, the discussion was purely technical and financial. There was very little emotional or political debate. The final vote approved NovaBuild as the lead structural integration partner for the project. The German firm was reassigned to provide steel materials and support engineering consultation. Construction planning started immediately after contract restructuring. 6 months later, full construction began. At the beginning, several senior site engineers were unsure about the hybrid integration method. Training programs were conducted for installation crews. Precision placement procedures were introduced for lattice integration sections. Luis Mendoza relocated to Dubai for the duration of the structural phase. Hassan worked directly with him during structural assembly coordination. During early construction phases, unexpected advantages started appearing. Because the hybrid system reduced total building weight, foundation excavation depth requirements were reduced. This lowered material costs and reduced construction time in early phases. Material transport logistics became easier because composite reinforcement materials were lighter than equivalent steel reinforcement structures. During mid-construction wind tunnel verification testing, the structure exceeded minimum safety margins by approximately 15 to 18%. This created additional long-term safety buffer, which increased investor and insurance confidence in the project. International engineering publications began covering the project. Structural engineering universities requested research collaboration data. Construction companies from multiple regions sent technical observers to study the hybrid reinforcement installation process. As construction progressed, engineers noticed reduced vibration stress transfer between major frame sections during controlled movement testing. This confirmed earlier simulation predictions. The building was completed slightly ahead of schedule. Because of total structural weight savings, the tower design was extended by 2 additional floors without requiring major core redesign. Final structural inspection testing showed strong stress distribution balance and no unexpected joint fatigue concentration zones. At the official opening ceremony, Hassan made a public statement acknowledging that he originally rejected the hybrid reinforcement concept because it was unfamiliar. He explained that structural engineering decisions must always be based on complete data evaluation, not first impressions or past material bias. Luis kept his message simple and technical. He stated that engineering progress depends on testing new materials using real-world data and long-term performance observation. Within 1 year, Novabuild received multiple new structural contracts across the Middle East region. Desert Core Construction Group formed a long-term research partnership with Novabuild to develop future hybrid reinforcement systems. Several new regional tower projects began testing modified hybrid reinforcement methods adapted for desert climate performance conditions. Over time, the Skyrise Eco Tower continued performing above predicted structural stability projections. The project became a case study example in structural engineering training programs and sustainability-focused construction research. For Hassan personally, the project permanently changed his professional evaluation process. He continued using traditional materials when proven effective, but he no longer rejected new engineering approaches without full technical validation. The project demonstrated that modern engineering progress does not come from replacing traditional methods. It comes from testing new ideas alongside proven systems and allowing data to guide final decisions. Years later, the tower remained one of the most structurally stable and environmentally efficient commercial buildings in the region. And for the industry, the project became proof that innovation and experience can work together when decisions are based on evidence instead of assumption.